Out-of-this-world images released today thanks to the James Webb Telescope.
Look back to the early formation of the universe, and it's been doing just that. It has taken pictures of 6 galaxies.
So these are the stunning images from the James Webb Space Telescope, currently in space 1 million miles away from Earth.
Can a telescope change how we see the universe? In James Webb Telescope, captured what's at the end of the observable universe, we explore amazing new findings from the James Webb Space Telescope, JWST. This powerful telescope has spotted ancient galaxies that formed just after the Big Bang, surprising scientists and changing what we thought we knew about space. What mysteries lie in the darkness of the universe? Are we alone in this vast cosmos, or is something watching us from the shadows? Get ready for an exhilarating journey through the depths of space. This is just the beginning. The James Webb Space Telescope, JWST, is transforming our grasp of the universe with breathtaking discoveries. Launched to explore the cosmos like never before, it reveals ancient galaxies formed just a few hundred million years after the Big Bang, challenging our understanding of galaxy formation and dark matter. With its advanced infrared technology, the JWST allows us to witness the birth of stars and galaxies, revolutionizing our view of cosmic evolution. But this leap in astronomical discovery prompts deeper questions about our place in the universe and the potential for extraterrestrial life. As scientists decode this treasure trove of data, we find ourselves at a critical juncture in cosmic exploration, pushing the limits of human knowledge. The JWST isn't just unveiling the mysteries of the cosmos, it's reshaping the future of astronomy and compelling us to reflect on the implications of these revelations for humanity. Unveiling the ancient universe with JWST. The James Webb Space Telescope, JWST, has significantly expanded our understanding of the universe, enabling us to look back an astonishing 13.8 billion years to witness the first galaxies as their light reaches us. This achievement is not just a scientific milestone, it's an invitation to explore the universe in its infancy, offering a glimpse into a time when the cosmos was still taking shape. Equipped with advanced infrared capabilities, JWST captures ancient cosmic signals, revealing stunning images that deepen our knowledge of our origins. Galaxies began to form just a few hundred million years after the Big Bang, and JWST provides the clearest view of this formative era, challenging and refining our existing models of galaxy formation. Previously, we believed that galaxies took much longer to evolve. However, JWST's findings indicate that the universe was far more active in its youth than previously imagined. This groundbreaking work has unearthed a diverse array of galaxy shapes and structures, showcasing the rich tapestry of cosmic evolution. The remarkable capabilities of this telescope have reshaped our understanding of how galaxies grow and evolve. What was once thought to be a quiet and barren expanse of space is now recognized as a dynamic arena of star formation and galaxy interactions. This paradigm shift compels us to reconsider the early stars, known as population 3 stars. These massive giants, composed solely of hydrogen and helium, burned brightly yet lived short lives. Their explosive supernovae were not mere endings. They scattered heavy elements across the universe, seeding the birth of new stars and galaxies. The discovery that these massive stars existed and created the fundamental building blocks of the universe suggests that the early days of cosmic history were filled with much more activity than we had previously envisioned. This revelation raises important questions about how these early stars influenced the structure of the galaxies that followed, and what role they played in shaping the cosmic web we observe today. These inquiries inspire further investigation into the intricate dynamics of early cosmic evolution. As we delve deeper into the early universe, we uncover not only massive stars but also the remarkable processes that brought them to life. Formed from the primordial clouds of gas and dust left in the wake of the Big Bang, these ancient giants significantly shaped our cosmos. Their explosive supernovae scattered heavy elements throughout the universe, acting as the seeds for the formation of new stars and galaxies. This cosmic dance raises intriguing questions. How did these brilliant stars influence the formation of galaxies? What patterns emerged from their dramatic deaths? Each revelation pulls us further into a vibrant universe that continually challenges our understanding of the cosmos and our place within it. Simultaneously, we confront the limits of our knowledge about the observable universe. The JWST's discoveries urge us to explore beyond what we can see, awakening our curiosity about hidden mysteries. What secrets lie just out of reach? The concept of the observable universe highlights that we glimpse only a fraction of reality. with each distant galaxy offering a peek into a young cosmos filled with untold stories. Every insight invites us on an exciting journey, pushing us to expand our understanding and uncover the profound truths within the universe, challenging the boundaries of our cosmic knowledge. One of the most profound ideas brought forward by the JWST is the concept of the observable universe, the portion of space we can see due to the finite speed of light and the expansion of the cosmos. But what lies beyond? The discoveries made by the JWST take us to the very edge of what's visible, yet they invite the question, what remains hidden beyond this frontier? This isn't a physical wall, but a limitation set by the speed of light and time itself. Every observation of distant galaxies is a glimpse into a younger universe, one that may be vastly different from the present-day cosmos. The JWST's findings challenge cosmological theories, particularly the theory of inflation, which posits that the universe expanded exponentially fast in the moments following the Big Bang. Now, with JWST data revealing structures that seemingly contradict this rapid expansion, astronomers are left with new puzzles about the early universe's behavior. The existence of primordial galaxies detected at astonishing distances suggests that the conditions during the first few 100 million years were remarkably conducive to galaxy formation. Could the observable universe be just one bubble in a much larger, possibly infinite multiverse? This idea, once relegated to the realm of theoretical physics, now gains traction as a potential explanation for the anomalies observed in the early universe. Such a perspective challenges our understanding of reality itself and invites us to consider the implications of countless other universes, each with its own laws of physics and constants. This sparks deep philosophical questions about our understanding of time, space, and the very nature of existence. As we contemplate the potential existence of other universes, we begin to wonder, what do these findings mean for humanity? If our universe is but one of many, how does that influence our search for meaning and purpose? The JWST not only sheds light on the cosmos, but also reflects our innate curiosity and desire to understand our place in the grand tapestry of reality. With every distant galaxy it unveils, the JWST beckons us to reflect on our place within this grand cosmic narrative, urging us to ponder the significance of our journey through space and time. It's a journey that intertwines science with philosophy, compelling us to seek connections between our lives and the universe at large. What might lie beyond the confines of our universe, waiting to be discovered? Each finding stirs the imagination, inviting us to explore not just the physical cosmos, but also the metaphysical implications of a reality filled with infinite possibilities. In this grand adventure, we are called not just to look outward, but to search inward, examining the essence of our existence in light of the universe's profound mysteries. Exploring dark matter, dark energy, and the cosmic puzzle, JWST's observations are more than just a visual feast. They shed light on two of the most mysterious and dominant forces in the universe, dark matter and dark energy. Together, these entities make up about 95% of the universe's total mass energy content, yet they remain largely invisible and poorly understood. Dark matter, which does not emit, absorb, or reflect light, is detected only through its gravitational effects. With its advanced infrared sensors, JWST offers new ways of observing the influence of dark matter on galaxies at the furthest edges of the observable universe. This is where dark matter's gravitational pull plays a crucial role in shaping the formation of galaxies. In some of JWST's most exciting findings, scientists are mapping the distribution of dark matter in galaxy clusters, revealing how it acts as a scaffolding for visible matter to accumulate. These observations may help us understand the role of dark matter in galaxy formation and evolution. Are the structures we see today simply the remnants of this dark matter scaffolding, or do they also reflect the histories of the visible galaxies we observe? Each discovery invites a deeper inquiry into the nature of dark matter and its potential interactions with ordinary matter. Equally significant is the question of dark energy, the force believed to drive the accelerated expansion of the universe. The discovery of dark energy in the late 1990s transformed our understanding of the cosmos, but many questions remain. JWST allows us to measure the universe's expansion rate more precisely than ever before. But what is dark energy? Is it constant, or does it evolve over time? Could the universe's fate hinge on this elusive force? Some alternative theories even suggest that dark energy could change over time, growing stronger or weaker as the universe continues its expansion. As JWST gathers data, it may provide insights into the behavior of dark energy and its role in the cosmic fabric. Could dark energy be a manifestation of an unknown aspect of physics, or does it indicate something more profound about the universe's future? As we grapple with these questions, we begin to see the interconnectedness of dark matter, dark energy, and the visible universe, each playing a crucial role in shaping the cosmos as we know it. The implications of these discoveries extend beyond mere observation. They hold the potential to revolutionize our understanding of fundamental physics and the universe's ultimate destiny. As we explore the cosmos with the James Webb Space Telescope, the mysteries of dark matter and dark energy reveal their crucial role in shaping galaxies and their supermassive black holes. These unseen forces are not just background elements, they actively influence the universe's structure. Imagine if dark matter's gravitational pull affects how black holes grow, with dark energy pushing their development further. The connections between these enigmatic forces invite us to see the universe as an interconnected tapestry, where each discovery uncovers not just cosmic secrets, but also our place within it. This journey isn't merely about the past, it's a quest to understand fundamental truths and contemplate life's deeper questions. As we gaze at the stars, the revelations ahead have the potential to transform everything we think we know. A glimpse into black holes and early galactic mysteries. In addition to its revelations about the farthest galaxies, JWST is shedding light, quite literally, on some of the darkest objects in the universe, black holes. These enigmatic giants, often found at the centers of galaxies, have perplexed astronomers for decades. With masses millions or even billions of times that of the Sun, supermassive black holes formed relatively early in cosmic history. But how did they grow so large, so fast? This question has baffled scientists, and the JWST is perfectly equipped to study this phenomenon, capturing data that may reveal the processes that allowed black holes to form and dominate in the early universe. The telescope's infrared capabilities enable it to observe the accretion disks around these black holes, disks of gas and dust spiraling into the abyss. As material falls into a black hole, it heats up and emits intense radiation, making it one of the brightest phenomena in the universe. By studying the light emitted from these disks, astronomers can glean insights into the growth rates and behaviors of black holes in the early universe. This research could unravel the mystery of how these colossal entities influence their host galaxies and shape the cosmic landscape. Moreover, JWST's ability to observe early galaxies allows researchers to investigate the relationship between black holes and their host galaxies. How do black holes affect star formation? Do they regulate the growth of galaxies, or do galaxies shape their black holes? These questions are at the forefront of astronomical research, and JWST's discoveries will provide critical data to answer them. JWST's infrared capabilities also allow it to study the evolution of protoplanetary disks, vast swirling clouds of gas and dust that form around young stars, eventually coalescing into planets. By analyzing these disks in unprecedented detail, the telescope offers critical clues about the formation of Earth-like planets, not only in our galaxy but potentially throughout the universe. This exploration invites us to consider the conditions necessary for planet formation and the potential for habitable worlds beyond our own. What secrets might these planetary nurseries hold? And how common might Earth-like worlds truly be? Such insights could answer one of the most profound questions humans have ever asked. Are we alone in the universe? The exploration of protoplanetary disks holds the promise of discovering new planets, some of which may harbor the conditions for life. The quest for extraterrestrial life is not merely about finding another planet. It is about understanding our own place in the cosmos and the conditions that foster life. Exploring protoplanetary disks ignites our wonder about potential Earth-like worlds beyond our planet. Each disk hints at new planets that could support life, deepening our curiosity about the cosmos. This quest is not just about finding a new home. It encourages us to reflect on our humanity and our place in the universe. Insights from these explorations reshape our understanding of life, prompting us to question our origins and future. As we contemplate extraterrestrial life, we confront the essence of our existence. The JWST's discoveries not only unveil cosmic secrets, but also enhance our understanding of our role in the grand tapestry of existence. The implications of JWST, philosophical and scientific insights, The discoveries made by the James Webb Space Telescope go beyond the realm of science and delve into the philosophical. As we uncover the universe's oldest secrets, we are faced with profound questions about the nature of existence itself. What does it mean to exist in a universe that is 13.8 billion years old, that is constantly expanding, and that is filled with forces and phenomena beyond our comprehension? The implications of these findings prompt us to reconsider our place in the cosmos and challenge not just scientific theories, but also the way we view our own existence. The potential impact of JWST's discoveries on our understanding of life and intelligence cannot be overstated. As we search for signs of life on distant exoplanets and unravel the processes that led to our own existence, we begin to contemplate the broader implications of our findings. If life arose on Earth, could it also exist elsewhere in the universe? The quest for understanding life's origins is intertwined with the broader narrative of humanity's search for purpose and meaning. Furthermore, as we confront the realities of our universe, dark matter, dark energy, black holes, and the intricate dance of galaxies, we are reminded of our limitations in understanding these vast concepts. The pursuit of knowledge is an eternal journey, marked by the realization that each answer leads to new questions. The JWST's findings challenge our imaginations, pushing us to explore not only the physical cosmos, but also the philosophical implications of our existence. Moreover, JWST's discoveries have the potential to inspire the next generation of scientists, thinkers, and dreamers. The images and data produced by the telescope serve as a beacon of curiosity, igniting a passion for exploration and a desire to push the boundaries of human knowledge. By engaging with the cosmos, we foster a sense of wonder that transcends scientific understanding. We connect with something greater than ourselves, embracing the infinite possibilities that lie within the universe. To sum up, the James Webb Space Telescope is more than just a scientific instrument. It is a gateway to understanding our place in the universe. The discoveries it uncovers, ancient galaxies, dark matter, black holes, and the conditions for life, are not merely facts to be recorded, but stories waiting to be told. Each revelation adds a brushstroke to the grand cosmic portrait, allowing us to appreciate the beauty and complexity of the universe we inhabit. As we wrap up our exploration of the James Webb Space Telescope's stunning revelations, it's evident that these groundbreaking discoveries challenge our understanding of the universe and our place within it. What are your thoughts on the implications of these findings for humanity and the search for extraterrestrial life? We invite you to share your insights in the comments. If you enjoyed this discussion and want to stay updated on more fascinating cosmic discoveries, don't forget to like, subscribe, and hit the bell icon. Thanks for joining us. Stay tuned for more captivating stories and explorations of the universe.